square root. So remember, a perfect square is two numbers that multiply together to give us a square root. So in order to approximate the square root, we're going to deal with those numbers that are not perfect squares, okay? Those numbers that there's no number out, no whole number out there you can multiply by itself to get you this number. So there's two steps that you're going to do in order to figure out what this number is, which is why you got calculators, because I'm trying to make it go a little faster for you. So step one, the first thing we're going to do is we're going to find the two perfect squares it's located between. We want to find the two perfect squares it's located between. This means we want to find the perfect square that comes before our number, and we want to find the perfect square that comes directly after our number. This is why I had you do finding the square roots when you came into class, because you need to get familiar with squares and square roots. Like I said, the more you know your perfect squares by memory, the easier this lesson is going to be for you. So step one, we want to find the two perfect squares, and we want to find where our number is located, and we want to find the perfect square that falls before and the perfect square that comes after. Once we do that, we can then move into step two. Step two is that we're going to square our decimals between our two perfect squares until we get to the closest answer without going over. So we want to square our decimals between the two perfect squares until we get to the closest of our answer without going over. A good starting point, just like when you do when you're dividing, you're doing long division and you're trying to figure out how many times the number will go into another number, you'll multiply that number by 5 to kind of see if you should go up or down. Another good place when you're doing these decimal activities is to start at 0.5. When you start at 0.5, that'll tell you, am I really close to my number? Am I over my number? Am I way far away from my number? And from there, you know, do I need to try 0.6? Do I need to try 0.9? Do I need to try 0.2 maybe, even 0.1? So this may seem a little confusing for now, but I'm about to work through a problem, and I think once I work through a problem and show you these steps in actual action, it'll make sense. Alyssa, are you taking notes on this? What's on the screen? Just making sure. All right, does everyone have this copied down? Okay, let's look at an example. So the first one I'm going to do is the square root of 23. Now, the square root of 23 is not a perfect square, okay? There's no two numbers out there that'll multiply together to give us 23. No whole numbers, at least. So the first thing that I need to do is I need to find the perfect square that comes before 23 and the perfect square that comes right after 23. Jay, do you think you know?
No, I'm saying I didn't say that. No.
I don't know what no means.
I think you were saying.
Oh, were you still copying, Jenna? Okay, while Jenna copies real quick, I want you to look at those square roots, the activity that we did, and find what two of your square roots that you just found would 23 fall between. Remember, you want to find where 23 will fall between. You want the number the perfect square that would come before the square root of 23 and this perfect square that would come after the square root of 23. Okay, what do we got? Anyone have one? Christopher? 5. Okay, what's 5 square? 25, good. So the square root of 25, that's a perfect square, perfect. Okay, what perfect square would come before the square root of 23? Kirsten?
4.
Okay, and what's 4?
16.
The square root of 16, perfect. So the first step is we want to figure out where my square root's gonna fall, and y'all did great. It falls between the square root of 16 and the square root of 25. Now, if I square my perfect squares, that means my number is going to land somewhere between 4 and 5, okay? So now what I'm going to do is now I just want to start. I'm going to start at 4.5. You're always going to start with your smallest number is always going to be your whole number in this case, okay? And I'm just going to start at my 0.5 as my decimal. From there, I'll know if I can go up or if I can go down. So this is why I gave you your calculator, so it'll make things easier. So now what we're going to do is we're going to do 4.5 times 4.5. We're going to take the square root of it. We're going to square it. So 4.5 squared gives me 20.25. Do you think I can get closer than that? Oh yeah, I definitely. So what should I try? 4 point what? 7? I think that's a good one. Okay, so now let's try the square root of 4. Let's take 4.7 square. Remember, 4.7 square would be 4.7 times 4.7. Okay, well that gets me 22.09. Do you think I can get closer? We should probably see at least, right? We need to keep going until we go over. So that means we need to do 4.8 times 4.8, which is 23.04. So what do you think I should do for my perfect square? Which one should I choose? Or not my perfect square. What should I choose for my approximation of the square root? 4.7. Perfect. So I'm going to say that it is 4.7. The approximate of the square root of 23 is 4.7. Now you can get even closer to figure out what the approximate would be to move into the hundredths place. Do the same thing we just did in the tenths place in the hundredths place. So you would do 4.75 and then you try 4.73 like that. Does that make sense? So the closer, the further out you expand your decimal, the closer you're going to get to your actual answer. All right, so let's take a look at another one. So now let's figure out what are my perfect squares that surround the square root of 12. What are my two perfect squares that sandwich the square root of 12? Christopher? Okay, so the square root of 9 and the square root of 16. So everyone understand how I'm getting the square root of 9 and the square root of 16. Does that make sense so far? Yes? Okay, good. What is the square root of 9? 3. What's the square root of 16?
4.
4. Okay, so now I'm going to look in the middle of 3 and 4 to figure out, to try and get even closer to my answer. Okay, so like I said, guys, I always start with 3.5 square. I think 0.5 is the perfect place to tell you if you should go higher or lower. So let's do it with our calculators. 3.5 times 3.5. What'd y'all get? 3.5 times 3.5? What'd you get?
I got 12.20.
That's what I got.
Me too.
Okay. Okay, did I go over? Yeah, I went over, right? So 0.5 is not going to work. What should we try?
3.4.
You want to go down 1? Okay, let's try 3.4 square then. So remember, with your calculators, we're going to do 3.4 times 3.4. Oh, that gave us 11.56. What do you think? Should we stay there? Yeah. So we're going to say that the approximate square root of 12 would be approximately 3.4. What do we think? Is this easy, hard? Not too bad? Online, what do we think? We following along okay? It's all about knowing those perfect squares. If we don't know those perfect squares, then this lesson is going to be super hard. But you get to use a calculator. So you're welcome. You're welcome. Okay, so this time we're going to work out the square root of 72, but this time I want to find it to the nearest hundredth. Okay, to the nearest hundredth. I'm going to do the exact same thing, except this time, once I figure out the 10th place that's closer, I'm going to take it one step further, okay? So, first things first, though, I need to figure out what perfect squares surround the square root of 72. Jade, tell me one.
64.
Okay, the square root of 64. All right, I need someone else other than Jade and Christopher to tell me the other one. Kinsley. Square root of 81. Perfect. I love it. What is the square root of 64? 8. What's the square root of 981? Perfect. So now we need to find our 10th place. Remember, let's start with 8.5. Always start with that 0.5. Oops, sorry. So 8.5 times 8.5, what'd y'all get?
92.25.
Ooh, that's too big, right? What should we try? Let's try 8.4. So 8.4 times 8.4, and we get?
70.86.
Perfect. Now, I know my 10th place. So now I'm going to take it a step further. Now I'm going to keep my 8.4, but this time I'm going to add a 5 to the end of it. Because I want to take it to the 100th place. So now I'm going to do 8.45 square. 8.45 times 8.45, and what'd you get?
71.
Okay, 71.40 we'll say. Okay, so what should I try next then? If 0.45 gave me 70, what number you want to try? 8.4, you want to just try 0.6? Okay, 6. So 8.45 or 46. So 8.46 times 8.46, what'd you get? I got 71.57. What'd y'all get?
Yeah.
Okay, what do you want to try next? I don't think we should do 0.47. Okay. Let's try 8.48. 8.48 times 8.48. And that gave us 0.91. Do you think, should we just see what 78.49 would give us? Let's just see. So now let's try 8.49 square. So we're going to do 8.49 times 8.49. Addison, and that gave me 0.08. So that gets over. So we're going to stick then with 8.48. So the square root of 72 is approximately 8.48. Addison, what part don't you understand? Like, where are you getting confused? Okay, Addison or Jenna want to tell me? If not, I'm just going to have to move on if you're not. Okay, so the first part is we need to look at our number. So for instance, we looked at the square root of 72. And we needed to find the two perfect squares that go on either side of it. Remember, two perfect squares are two numbers that when multiplied together, they give us a number. So 8 times 8 is 64. So the square root of 64 is 8. 9 times 9 gives us this 81. So this basically 8 squared gives you 64. To do the opposite of squaring something, you square root it. That's going backwards. So you're trying to find out what two numbers multiplied together to give you the number inside your square root. So when I say we're trying to find perfect squares, we're trying to find those perfect, that from that perfect square list that I gave you for the bell ringer, You want to look on there and find where does 72 fall in between. 72 falls in between the square root of 64 and the square root of 81. Okay, because 72 comes between 64 and 81. And then the square root of 64 is 8, and the square root of 81 is 9. So all I'm doing, even with the square root of 12 right here, is I'm saying, okay, let me look at my list. What are two perfect squares that come on either side? Okay, I want to know where does the square root of 12 fall on that perfect square list. Let's look at another. Don't make me take your calculator. Let's take a look. Let me just make a random one. Let's do the square root of, someone give me a number. Any number. 8. The square root of 8. Oh, Anna, we'll do 50 next real quick. Okay, so the square root of 8. What, according to my list, look at my perfect square list. What is my what perfect square comes right before 8? With the square root of what? What comes before the square root of 8?
I see
The
you.
square root of 4.
I see you. I don't see your laptop thing, your shared screens.
Okay, so normally when that happens, there's a connection issue on your end, or like your internet's not connecting. Or the internet here, I don't know, guys. I don't know what to tell you. I'm so sorry. All I know is it's showing me that I'm connected. You can try to just listen along, and then you can try to leave and rejoin. You can try and watch the video later. I don't know what to tell you. I'm sorry. I wish I did.
Okay.
Okay, what perfect square comes after the square root of 8? Jade? The square root of 9. So this is the first part right here. All the first part is finding those perfect squares that come right before your number and right after your number. All right, does that make a little bit more sense? All right, just because Anna said 50, what are my perfect square? What perfect squares come before and after 50? What? 49, so the square root of 49. What comes right after 50? 64. So that means that the square root of 50 would fall somewhere between 7 and 8. Okay, so now that we know how to approximate square roots, let's talk now about how to compare and order rational versus irrational numbers. Okay, so now we're going to talk about how to compare and order real numbers. All right, so to compare, this is your other page of notes. To compare real numbers in different forms, you can rewrite irrational numbers as decimals. The key here is we're going to get everything into decimals. This is why our first lesson we talked about, not really. We talked about repeating decimals to fractions, but that's why we talked about how to approximate square roots in the decimals, because any fraction that we have, our square root, we're going to make them decimals, okay? We want to compare everything in decimal form. Can anyone look back in their notes and tell me what real numbers are? What are real numbers? Colton, get it off your head. Come on now.
Oh, I forgot it was in my head.
I'm sure you did.
I did.
All right, real numbers. Who can tell me what the definition of a real number is? Kirsten? Are real numbers on that list?
No, it's only natural numbers.
Oh,
And
natural, whole numbers, integers, and rational numbers, and irrational.
okay. What if I just told you that Kirsten just told me what a real number was?
Oh, I got it. Natural numbers.
Not just natural, all of them. All of them are real numbers. All of them are real. I mean, you don't have to, but. All right, so to compare them, I want to put everything in decimal form. My 5, do I need to put that 5 in decimal form?
No.
No, my 5's a whole number, but the square root of 10, I can't really compare that to 5, can I? No. So in order to compare that to 5, I need to approximate it, and then I can compare it. So remember, to approximate this, yeah, sorry, I need to find what are my perfect squares before and after 10. So what perfect square comes before 10? What?
9.
The square root of 9. Okay, what perfect square comes after 10? 16. All right, what's the square root of 9?
3.
What's the square root of 16?
4.
4. All right, so my approximate value is going to come somewhere between here. So let's try 3.5 square. What does 3.5 times 3.5 give us? 12.25. That's too big, right? We should probably hop down quite a bit. What do you want to try? 3 point what?
3.6.
3.3. Okay, that's a good option. So 3.3 times 3.3. 1089. Still a little too high, right? What do you want to try? 3.2. That's a good choice. Good choice. So 3.2 times 3.2. 10.24, man. So we're going to try 3.1. 3.1 times 3.1, that gives me 9.61. That's my sweet spot. So instead of looking at this as the square root of 10, we're going to look at it as the square root of 3.1. So, what number is bigger, 5 or 3.1?
5.
So 5 is greater than 3.1. Okay, all right, so what do we think? Not too bad, right? It really helps getting to use the calculator. Like if you had to do this all by hand, it would take forever. All right, let's take a look at another one now. Let's try 8.25 and compare it. Take a little look at our cheat sheet. What square roots come before and after the square root of 99? Christopher, you were just on this. You like this, don't you? All right, what square root comes before the square root of 99? 81, good. Someone other than Christopher, just to steal some of his joy. Kinsley. Okay, the square root of 100. I had to think for a second. For some reason, I was like, there's a square root of 100? What is the square root of 100? 10. Miss Shelley's silly and forgot. Well, what's the square root of 81? 9. All right, so where should we start? You want to start at 9.5? Okay, let's just start at 9.5. That'll give us a good basis. So 9.5 times 9.5, that gives me 90.25. I think we can go up quite a bit. What do you think? 9.8, that's what I was thinking. So let's try 9.8 square. So 9.8 times 9.8, that gives me 96.04. So we'll just try 9.9. Yeah, that's going to give us the closest. So now we're going to pretend this number is 9.9. So what number is bigger, 8.25 or 9.9?
9.9.
Perfect. So 8.25 is less than the square root of 99. Okay, so Addison, you are going to look at your chart, your perfect squares, the perfect square roots, and you need to find the perfect square root that 99 falls between. So look at that list and see, okay, 99 comes in between 81 and 100. And then you'll take those square roots, and that's how you get the 9 and the 10. You could have what?
Nothing, I was just thinking to myself, we could just put it a decimal in the middle and try, hopefully guess it on right.
All right, so now we're going to step it up a notch. Step it up a notch. So now I have the square root of 8 over 2. Remember, I want to compare everything in decimals. I can figure out what 13 into 4 is. I can just do 13 divided by 4 on my calculator, and that tells me what'd you get. I know what I got, but what did you get? Do 13 divided by 4. What'd you get?
3.25.
Now, before I can do that to the other side, I've got to approximate and figure out what the square root of 8 is. Okay? So let's come down here and let's figure out what the square root of 8 is. Okay. What two square roots does 8 fall between? Kirsten?
Are we doing both of them or just one?
Let's just name both. Why not?
4 and 9.
4 and 9. Okay, what is the square root of 4? 2. What is the square root of 9?
3.
Do you notice in every single one of these problems, when we figure out what the square root is, the numbers are always one off from each other? It's always 2, 3. Over here it was 9, 10. Over here it was 3, 4. If your numbers aren't like that, you did something wrong. Okay, my screen is taking just a second to catch back up to where we're at. Okay, so now I need to figure out, try and get a little bit closer. So we're going to try 2.5. So 2.5 squared. So 2.5 times 2.5 gives us 6.25. All right, what do we want to try? We're quite far. Kinsley? Let's try 2.8. I like that, Kinsley. So 2.8 squared, which is 2.8 times 2.8. That gives us 0.84. That's pretty close. You think we can get closer?
Yes.
All right, well, let's see. I don't know.
One more.
All right, 2.9 squared. So 2.9 times 2.9 gives me 8.41. Oh, man. So what should we have stuck with? 2.8. So instead of looking at this 2.8, we're going to now look at it as square root of 8. We're now going to look at it as 2.8. So now in our calculators, we're going to do 2.8 divided by 2. And what is that going to get us? 1.4. So now we can see what number is bigger, 1.4 or 3.25. So that means that the square root of 8 divided by 2 is less than 13 over 4. What do we think?
Pretty easy.
Not too bad? I think if you know your perfect squares, it's even easier. And you get to use a calculator, so that makes it even easier. Well, let's step it up a notch. Comparing expressions with irrational numbers. Bum, bum, bum. How do I compare expressions with irrational numbers? Well, the first thing that I want to do is I want to rewrite my irrational number to decimal. Notice a commonality with the other thing. We want everything to be decimals. Then I'm going to simplify the expression. And then I'm going to compare the two values. So first I'm going to rewrite all irrational numbers to decimals. Then I'm going to simplify the expression, and then I'm going to compare the two values. All right, so let's take a look. Okay, do not freak out. The first thing we need to do is we need to figure out what the square root of 2 and the square root of 4 is. So let's start with the square root of 2. What's the square root of 2? Is it a perfect square? No. So we've got to approximate it. Oh, sorry, Jenna. All right. I'm trying to see if I can't. I took a screenshot, so I'm going to try and see if I can upload it to the comments of the chat. Yes.
Sorry, I have a question. It's
What?
not really precise, but who knows, you might know. So how come whenever you blow, like you're whistling, it comes out cold,
No idea.
but whenever you go, it's hot?
No idea.
What?
Oh, now you're done. Oh, well, I sent a picture just in case. Okay, so first thing we need to do is we need to figure out what the square root of 2 is. So what are my perfect squares around the square root of 2? The square root of 1 and the square root of 4. What is the square root of 1? 1. And what's the square root of 2? Or 4? 2. So now I'm going to go in between. So 1.5 squared to get me as close to 2 as possible. So 1.5 times 1.5 gives me 2.25. What should we try? 1.3 or 1.4?
1.43.
Ooh, what should I try? 1.3 or 1.4?
1.4.
I heard of more 1.4s. So 1.4 times 1.4, that gives me 1.96. I don't think we're going to get closer. So instead of the square root of 2, I'm now going to look at this as the square, or 1.4. So what is 1.4 plus 4?
5.96.
So 1.4 plus 4 is 1.5. Okay. What do is the square root of 4, is that a perfect square?
Yes.
Yeah. Oh wait, that should be 5. Oh, Miss Shelley just completely wrote her numbers off. 1.4 plus 4 is 5.4. All right. What is the square root of 4? 2. What is 2 plus 2? 4. What don't you get? We found that the approximate square root of 2 is 1.4, so then we did 1.4 plus 4, which gave us 5.4. Okay, guys, so I found that the square root of 2 is 1.4, so I added that to my 4. I plugged that in up here, so I got rid of the square root of 2 and put 1.4. And so I did 1.4 plus 4, and when I add that together, it gives me 5.4. Uh-huh.
I have a question about this. So, is there any way that like decimal right there and decimal?
No,
right
you can
there?
only have one decimal number. Okay, so what number is bigger, 5.4 or 4? 5.4. So that means that in my original problem, the square root of 2 plus 4 is greater than 2 plus the square root of 4. Okay, let's take a look at another problem. Now I have the square root of the square root of 12 plus 6, and I want to compare that to 12 plus the square root of 6. Is the square root of 12 a perfect square? No, so I need to find the approximate value. So what two numbers fall in between the square root of 12? Alyssa?
9 and 16.
The square root of 9 and the square root of 16. What is the square root of 9?
9 is 3.
What's the square root of 16?
4.
4. I was about to say it. Okay. So that means that the approximate value of the square root of 12 is going to fall somewhere between 3 and 4. It can't be 3, that would be too low, because that would be 9. And it can't be 4, because that would be too high, that would be 16. So that means that I'm going to use decimals now to get as close as possible without going over. So I'm going to try 3.5. Always try my 0.5. So 3.5 times 3.5 is going to give me what? So 12.25. Is that bigger or smaller? Bigger. So I need to go lower. What should I try? 3.4 square. Okay, so what is 3.4 times 3.4? 11.56. Okay, so what I'm going to do now is I am going to, see, I don't know if this will work. I'm going to take, and I'm going to get rid of the square root of 12. Is this not dark enough? I don't know if I can get it dark enough. So instead of it being the square root of 12, it's now I'm going to replace it with 11.56. So 11.56 plus 6. So 11.56 plus 6 would be 6, 5, bring my decimal down, 6 plus 1 is 7, so 1. So that means this would be 17.56. So now I need to figure out, is the square root of 6 a perfect square? No, so I need to now approximate that. What two perfect squares does 6 fall between? The square root of 4 and the square root of 9. What is the square root of 4? What is the square root of 9? That means the square root of 6, it falls somewhere between 2 and 3. It can't be 2 and it can't be 3. So we're going to try 2.5 square. So we're going to do 2.5 times 2.5, and what does that give me? All right, so we want to try 2.4, I take it? 2.4 square, so that'd be 2.4 times 2.4. All right, so that means instead of the square root of 6, we are going to replace that with the approximate value, which is 5.76. So now I need to add 12 plus 5.76. So that gives me 0.76, 5, 6, 7, and 1. So now I have to figure out what number is bigger, 17.56 or 17.76? 17.76. Anna, I put 12.00 because I originally my number was 12 up here, so it was just 12, and I had 5.76. The rules of adding with decimals tell me to line up my decimal place and fill in any blanks. After 12, I had blanks, so I just put zeros. But we talked about that last year in 6th grade math.
Yeah, we're in 7th grade exam.
Just like over here for 6, I put 0.00 because I just had 6 and I had holes. You're going to miss out on the lesson, but sure. Okay, same thing here. Let's figure out what the square root of 3 is. Is the square root of 3 a perfect square? Okay, what two squares fall? Does the square root of 3 fall in between? The square root of 1 and the square root of 4. What's the square root of 1? What's the square root of 4? All right, so that means my number falls somewhere between 1 and 2. So 1.5 times 1.5 is? All right, what should we do? What number should we try? 1.7? Christopher beat you. So 1.7 times 1.7, that gives me 2.89. You think we get closer? Okay, let's try 1.8 square. What's 1.8 times 1.8? 3.24. So what number should we go with? 1.7. So remember, we're going to get rid of this square root of 3 now. And now that square root of 3 is going to be 1.7. So we're going to come down here, we're going to do 1.7 plus 5. I'm going to put my decimal and add in. 5 plus 0 is 5. Drop my decimal. 1 plus 5 is 6. So now I'm going to rewrite this expression. I'm just going to rewrite it here as 6.5. All right. So now I need to figure out what the approximate value of the square root of 5 is. What two perfect squares does the square root of 5 fall in between? Jade?
No, where did you get 1.5 from? 1.5.
Oh, I'm sorry, guys. Shelly is obviously not thinking right. That should be 1.7. So that should be 6.7. 6.7. Thank you. Okay, back to my other question though. What perfect squares does the square root of 5 fall in between?
4 and 9.
The square root of 4, the square root of 9. What is the square root of 4?
2.
What is the square root of 9?
3.
3. So that means the approximate value of the square root of 5 falls somewhere between 2 and 3. So let's start at 2.5. What is 2.5 times 2.5?
6.25.
Ooh, did we overestimate there? Quite a bit, didn't we? All right, so what number should we try?
2.2.
I heard 2.3 first. So let's try 2.3 times 2.3, and that gives us 5.29. We're still over. So do we want to try 2.1 or 2.2? 2.2, okay. I feel like y'all already did this. Did y'all go ahead? Wow, y'all like this so much. Some of you went ahead and went on and solved it. So I'm going to get rid of coloring out my thing so I can rewrite. My new number is 2.2. So now I need to come down here and add 2.2 plus 3. I'm going to add a decimal to 0 as a filler. 2 plus 0 is 2. 2 plus 3 is 5. So now I need to compare what number is bigger, 6.7 or 2.5?
6.7.
So what do we think? Not too shabby? Okay,
How much longer is for this?
we have one more step.
Oh, yeah, one more and then
Yeah.
we'll go to worksheet.
Yep, one more. So now we've talked about how to compare. We've talked about how to compare rational to irrational numbers. Now let's talk about how to order real numbers. Order real numbers. We're going to skip that one. You can work on that and let me know the answer. And I can tell you if you got it. You don't have to, but you can do it. See if you got it right or wrong. But let's talk about how to order real numbers. 3 steps that we need to do. Actually, 2.5 really. The first thing that we need to do is we need to convert all of our numbers in all forms into decimals. The most important part of this, and you might want to like underline or highlight it or whatever, is we want to make sure that we round them to the same decimal place, okay? It's very hard and not a true answer if we round some to the tenths, some to the hundredths, and some to the millionths, all right? So we need to pick a decimal place and we need to round to that. The next step is going to be one of those if you need to things. And that would be to plot your decimals on a number line. You don't have to do this. I'm not going to require you to do this. If it would help you order them, then I would do it. And then finally, you want to list your numbers from left to right to put them in order from least to greatest. Now, this third step's not my favorite. If I was to rewrite this third step, I would write it as something like, put them in the order the question asks you. Because the questions don't always ask you to go from least to greatest, do they? Sometimes they're going to ask you greatest to least. So make sure you pay attention to what the questions are asking you, what order it's asking you to put them into. All right, and just in case our kids at home, you're not finished, I'm taking a quick snap of this picture of this slide and I'm sending it in the chat. So that way, just in case you're not quite ready, you didn't quite finish all your notes. Oh, my Apple Pencil's running low. Hopefully I make it. Then the notes are in the chat. Okay, first thing we need to do is we need to put these in order. Okay, from least to greatest. The square root of 22, is it perfect?
No.
No, so we need to approximate it. Okay, what two perfect squares does the square root of 22 fall between? Kinsley? The square root of 16 and the square root of 25. What is the square root of 16?
4.
What is the square root of 25? So it falls somewhere between 4 and 5. So we'll start with 4.5. What is 4.5 square? 4.5 times 4.5 is? 20.25. What number should we try next? 4.8, okay. What's 4.8 times 4.8? Oh, that went way over. What do you want to try then? 4.7, okay. What's 4.7 times 4.7? Oh, that still goes over, doesn't it? So let's do 4.6 square. 4.6 times 4.6 is? 21.16. Okay, so now I'm going to look at this as 21.16. Okay? So since I'm doing 21.16, we can do the hundredths. Okay, what is pi? Okay, remember, we only want the first two digits after the decimal, so 3.14. Okay. Oh, plus 1. I didn't see that plus 1. What's 3.1? Oops. What is 3.14 plus 1?
4.14.
4.14. So now this whole thing is going to be 4.14. What is 4 1/2? What is 1 divided by 2? Well, let's do it real quick. Let's do 1 into 2. 1 goes into 2. Wait, I did that backwards. Sorry, guys. That should be inside is 1, outside is 2. 2 goes into 1 how many times? 0. 1 minus 0 is 1. Add my decimal, pop it up. Add my 0, bring it down. How many times does 2 go into 10? 5. Kinsley, you have a question or you were just answering? What's your question?
So, when we are doing like how to estimate it, whatever like number it comes out, you have to make it like that always.
Oh, no. This shouldn't be 2.14. This should be 4.6. I'm sorry. You're correcting me? Thank you. Because I don't know why I did that. Did that answer your question, though? Okay, I'm so sorry about that. So basically, what I messed up, Kinsley corrected me. I put 21.16, the answer, when I should have put the square root. So I apologize. Or the square. Okay, and then we already know what the square root of 22, that's on there twice. So that would be 4.6.
On our paper,
There's no second one? Okay, so that was just an accident. Okay, so let's write these in order. So what is my smallest?
Giselle Reyes.
It would be
Please, Giselle Reyes.
4.1, right? So I want to, now, when you write these, you want to rewrite these in the order, in the original problem. So the original problem, it gave it to us, it was pi plus 1. So remember, we want to round them all to the same decimal. Since we did the square root of 22, we approximated that as 4.6. We only want one digit after pi, which is 3.1. Okay, so what comes next? 4.5. What number originally was 4.5? 4 1/2. Remember, you always want to rewrite your problem in the order of the how you originally had it, okay? And then finally, it was 4.6. And what is 4.6? The square root of 22. So this right here would be your final answer.
Anna said, why is pi
Because it was pi plus 1. You can't forget that plus 1. So we did 3.14 plus 1, which gave us 4.14. But we only wanted one digit, so we got rid of that 4. Does that make sense, Anna? Because it was pi plus 1. The whole expression. Okay. All right, let's take a look at one more. Ooh. All right, so. What? I know, class is almost over. Okay, so we need to figure out what the approximate value of the square root of 45 is. What two perfect squares does the square root of 45 fall between?
36 and 49.
Perfect, 36 and 49. What is the square root of 36?
6.
What's the square root of 49? 7. So we need to figure out, we need to go in between 6 and 7. So we'll start with 6.5 squared. What is 6.5 squared? 6.5, what is it?
42.25.
All right, so what do we want to try then?
6.7.
6.7?
Yeah.
Okay. I just had to move this over real quick. So 6.7 squared, 6.7 times 6.7 is,
44.89.
I don't think we're getting any closer, guys. Okay, so that means that we are now going to look at this. The square root of 45 is now going to be 6.7. Now, we know, what is pi again? So we are going to do 3.14 squared, which means we're going to do 3.14 times 3.14. And we're going to use calculators because we have them. What is 3.14 times 3.14?
9.85.
Now, we only want one digit.
9.8.
So we're going to, instead of pi squared, we're now going to look at it as 9.85. All right. And then we just have 10, which is fine. And what is 4 1/2 again? We just did this on the last one. So this is now going to be negative 4.5. All right, so let's put these in order from least to greatest. So if I graph these down here on my graph, negative 4 1/2 would be about here. 10 would be here. The square root, or pi square, would be 9.85. That'd be about there. And then the square root of 45 would be 6.7. That'd be about there. So do you see why sometimes graphing these can be helpful? Because now it puts it all in order for you. So now all you would have to do is just rewrite them out. So your final answer would be negative 4 1/2, the square root of 45, pi square, and 10.